So I'm Vicky Anderson. I'm Senior Systems Engineer at KISPE. Kernow Sat is a programme of work that we're doing with Spaceport Cornwall, and KISPE are namely involved in the Kernow Sat-1 satellite, which is a CubeSat satellite that's going to be used to get information from around kind of the coastline in Cornwall. So what we're going to have is a series of buoys in the marine environment, so kind of along the coastline, and these are going to have sensors on, and these sensors are going to give useful information or interesting information to the people in Cornwall. So for example, sea temperature, salinity, that kind of thing. And basically our satellite's going to come along and hoover up all that information and then pass it out to the people who are interested in it. So the community aspect is really exciting, and it's quite different to how a normal kind of space mission would be run. We're getting a lot of different parties involved, so schools, interested parties, sort of companies and things, and we're really looking at how we can do something that benefits Cornwall and really promotes space to perhaps a sector that may not have been aware of it beforehand. So we've really excitingly had our first piece of kit through, external kit through for Kernow Sat. It's called a Q computer, and it's from a company in South Africa called CubeSpace. Now, the Q computer is really important because when a satellite's in space, it kind of needs to know where it's pointing. So for our particular application, we're going to have all these buoys around the coast. We need to be looking at the buoys to be able to get the information from them. The Q computer performs attitude control, and so that basically tells you where your spacecraft is pointing. So, we've got all these sensors along the coast, and we need to point down at them to be able to hoover up the information. And so the satellite will use things like stars and the position of the sun to know kind of which way it's pointing. And the Q computer is the piece of equipment that takes the information from various sensors and tells the onboard computer, which KISPE is developing, which way round things are and what needs to happen next. When we received the Q computer from CubeSpace, what we start with is a health check to make sure it's got across the ocean okay and it's all going to work as expected. And what we're doing now is looking at bringing up the interfaces and making sure that it's going to interface with our onboard computer. So we have a setup here where we're looking at some of the different interfaces, so how we can talk to it, how we get information from it, and how we power it and those kind of things. And so that's what we're building up to. And ultimately we'll be looking to connect it to our own onboard computer rather than the development kit we have here. The Critical Design Review, or CDR, was a really important milestone for us on Kernow Sat. It basically looked at whether we had a whole complete design together and something that was going to satisfy the mission objectives that we set. So we looked at kind of all our different technical solutions and how they're going to work together and how they were going to work as something we called a concept of operations, so how they're going to work as part of the bigger ecosystem. Because although we're doing the satellite, you've also got to consider kind of how you're going to talk to the ground. So there's ground infrastructure. You've also got the payload element and the buoys, where you're actually going to get your information from, and those kinds of things too. So it was really nice to kind of bring everything together and see how those different parties are going to work together. So there are lots of really important factors that go into designing a spacecraft, whether it's a kind of a microsatellite or whether it's a CubeSat. CubeSats are smaller than kind of maybe some of the traditional satellites that people might recognise. And so one of the really big factors that we had to take into consideration was power. Power in space is generated through solar panels, and you only get power through those when you're in sunlight. And so you have periods where you're in eclipse and you don't generate any power, but you still want to be able to use your payload and do all those kind of fun and interesting things, even though you're not getting any energy generated. So a lot of work went into looking at the power analysis, kind of working out how big those panels and things need to be, and so that's formed the basis of quite a lot of our technical decisions. The other aspects sort of around attitude control, we went to find people who had kind of systems and things that would work and would be a complement to what we needed. And then we're actually developing our own onboard computer, and so we took the requirements that kind of came from these other subsystems, and that kind of led us down the development of our ABC, which we're going to be taking forward. So So what we have in setup here is our Cube computer, and you notice it's got various wires and things coming out of it. And this is very much a test setup at the moment, just kind of the unit on its own. As the program progresses, this setup will change significantly as we kind of get more into something that looks like a real satellite. But for now, kind of this is our kind of individual component testing sort of setup. So what we have here, this is the KISPE Cube computer board, and this is actually the although we're using this one in the lab here, this is exactly the same as the board that we would use in flight. So it's the same form factor. So this is a standard PC104 board size. So it's about 10 centimetres by 10 centimetres, give or take. And Kernow Sat is going to be what we call a 6U satellite. So effectively, it's about 30 centimetres by 20 centimetres, and that's the entire spacecraft. And what you have is all these boards, you have rails inside, and they all slide onto the rails, and that's how you build up your spacecraft. And so this here is just one slice, in effect, of ultimately what the whole satellite will be. So yes, this is a Q computer, and as I say, this has got various chips on it, and this is in the real system. When we have the rest of the bits, there'll be other pieces of equipment that will plug into this board. So there are things like wheels, which you can use to control the position of the satellite. There'll be sun sensors, which, as the name suggests, find the sun and tell you where the sun is. Magnetometers for measuring the magnetic fields, and magnetorquers for being able to use those magnetic fields to control your position. But this is literally the brains. This is the bit that kind of takes all those inputs and will drive all of those units when they're there. Now, you can see we've got various other bits and pieces hooked up here. This board here is a development board. So basically, it has a lot of different interfaces on that match what are on the Q computer, but this is a commercial off-the-shelf item, and it has microprocessors on, and it can basically allow us to run some software to talk to the Q computer and check that we can run our software and talk to it in the way that we expect. And some of these other boxes here are just providing some kind of interfacing between the various elements that we have. And basically what we're doing here is we're running some software on this board to check we can talk to the Q computer. And what we will do is we will replace this board with this board that we have here, which is our onboard computer. This is our engineering model. It's not the one that will be flying, but it's pretty close. So this board here, which you can see is the same form factor as the Cube computer, ultimately will take up kind of the functionality that's on this board, with some more bespoke items that are needed specifically for Kernow Sat. And so what we're basically doing at the moment is we have connection to the computer, so we can see from the perspective of the computer how the board is running, and we're powering it at the moment off of a power supply. In the real satellite, we would have a separate power system and batteries, because obviously you can't fly one of these, and that's what would take all the solar energy in and allow us to power all our other units.